A quick finish to our examples for graphing linear inequalities. On example 4, we had graphed the boundary line because the symbol is greater than or equal. We used a solid line indicating that the points on the line are solutions. We started plugging in the ordered pairs 0, 0 because it's not on the line to see if it worked in the original equation. 0 minus 7 is negative 7. Is that greater than or equal to 2 times 0 minus 13? 0 minus 13 is negative 13. Is negative 7 greater than or equal to negative 13? Yes, negative 7 is greater than negative 13. So 0, 0 is a solution. So you would shade all of the points on the side of 0, 0. All of the points on that side are solution, along with points on the line are solutions. The points that are below the line are not solutions. Moving on to review graphing vertical and horizontal lines. Y is greater than negative 6. If it's y is greater than negative 6, you could also write that y is greater than 0x minus 6. You could also come up with a list of ordered pairs that have a y value of negative 6. 0, negative 6, 1, negative 6, 2, negative 6. As long as the y value is negative 6, then they would fall on the boundary line y equals negative 6. When you plot all of those ordered pairs, you get a horizontal line with a slope of 0, and when we look at the symbol, it's greater than only. So we use a dashed line to represent that the points on the line are not solutions. The points on the line have a y value equal to negative 6. We only want points that have a y value greater than negative 6. If we check 0, 0, is 0 greater than negative 6? Yes, so all of the points above the line would represent the solutions to the inequality y is greater than negative 6. If we're graphing example 6, negative 2/3 x is greater than or equal to 4. First, we need to solve for x. Since we do not have a y value to solve for, we need to solve for x. We are going to multiply by the reciprocal, negative 3/2. We are multiplying by a negative. You cannot forget when you have an inequality symbol and you multiply by a negative, it changes the direction of the inequality. Negative 3/2 times negative 2/3 is positive 6/6, which is 1, leaving me with 1x, or x. Multiply on the other side, you get negative 12/2, which is negative 6. So when we solve for x, we get x is greater than or equal to negative 6. X only means it's only going to cross the x-axis. You can also list a bunch of points that have an x value of negative 6. Negative 6, 0. Negative 6, 2. Negative 6, negative 3. As long as x equals negative 6, it will fall on the line x equals negative 6. These will be points that fall on a vertical line. That's the only way it can cross the x-axis only. The slope is undefined. When we graph this line, because it's less than or equal to, we're going to use a solid line to graph the line x equals negative 6. Now we need to decide where x is less than negative 6. So we can test 0. 0 is not less than negative 6. So 0, 0 is not a solution. Therefore, we will shade the other side of the line. This would mean all the points to the left of the vertical line and points on the line are solutions to this ordered pair. If we plug in negative 9 for x, we get positive 18/3, which is positive 6. And 6 is greater than or equal to 4. So we just proved that the points to the left of the line are solutions to the original inequality. So here we see where we have to multiply by a negative. Anytime you multiply or divide by a negative, your inequality symbol switches. So in summary, graph your line, You can use intercepts if it's in standard form, or you can put it in slope-intercept form by solving for y. Decide if it's going to be solid. Solid is less than, equal to, greater than, equal to. Dashed is less than, greater than. A dashed line means the points on the line are not solutions. Once you've drawn your boundary line, decide which side of the inequality you want to shade. That's one clue that you have graphed an inequality, is there will always be shading when you have an inequality, because an inequality, one side of the boundary line would be solutions either less than or greater than. Now complete the practice problems on the attached pages. Thank you.